All right, video 6 is going to put it all together. Video 6 is talking about compositions. All right, so at this point, you should be able to do all reflections, all rotations, and all translations. All right, because composition, what a composition is it's performing multiple transformations. So that means we're going to have to do more than one thing in each question to each point. So by the end of this video, you should be able to define a composition and a sequence of rigid motions, perform a composition of a transformations, explain the sequence of rigid motions given two objects or shapes, and identify if two objects, shapes are congruent on the coordinate plane. This is really what the Regents questions look like, right? This is where kind of they all come from, and this is the topic that's going to be really important. So it includes all of videos 3, 4, and 5 are all kind of mixed into one here, and I'm going to show you how this kind of works. All right, so first let's get with the vocabulary right away. A composition is a combination of two or more transformations, each performed on the previous image. So just an example of what that looks like, all right, or how it's going to be shown, is you'll see something that looks like this. All right, so that is how a composition is written. So this O here, or this open circle, this stands for composition. All right, and composition, the key star here, tells us to work from right to left. So the first thing we're going to do in this one is we would do the reflection over the x-axis first, followed by a rotation of 90. So you must go in that order when you do a composition. If you do it the other way, it's not going to come out right. All right, the other way you can see this is with parentheses. So if I write the same one, it would look like this. So again, in this case, we're still working from right to left or from inside to outside. So if we do, it's a rotation of 90, a rotation of x-axis of the point P. I'm going to do this first, and I'm going to do this second. All right, that's really important. Now, this second part comes up all the time. If transformations in compositions are all rigid motions, then the figures are congruent. So if we have a composition set up and each transformation is a rigid motion, then our starting point and our ending point are going to be congruent. If it's two triangles, they're congruent. These are the kind of questions that are going to come up. All right, so next, a sequence of rigid motions. So this is just kind of a vocabulary, and this is what we're going to have to be able to repeat here. If there is a sequence of rigid motions that maps one figure onto another, then the figures are congruent. Again, that's kind of the same thing that I wrote here. These are pretty much the same thing. So if a figure undergoes multiple rigid motions, then the figures are congruent. All right, let's just get right into an example so I can show you how it's done, and hopefully some of the vocabulary will get cleaned up. So first example is find the coordinates of triangle QRS under the composition of rotation of 90 and a reflection over the y-axis. The one thing I want you to do, I did make a mistake. I didn't put these points on your packet. So please make sure you copy these points down. You would have to be given the 3 points. So this is Q, and this would be point R, and this would be point S. So again, I see this symbol for composition here, that little open circle. That tells me I must work right to left. So I'm going to list my points out. This is where, in those last couple videos, I made you list out all the points, because this is where I like to really list out the points, because it makes organizing my information much, much easier. So the first thing I'm going to do, if I'm working right to left, is I'm going to do a reflection over the y-axis. And a little review from video 3 here. A reflection over the y-axis, I change the x value, or I change the coordinate. So it's going to be -2, +2, -6, 4, and -4, 7. Now, if I wanted, I could graph that. It does say graph both images. All right, so that just means triangle QRS and the last one. So on the next one here, I'm going to do the second transformation. So here we're going to do a rotation of 90. And I'm going to get Q double prime, R double prime, S double prime. So remember, rotation of 90, I'm going to switch the coordinates, and negate the y value or change the sign of the y value. So negative 2, 2 is going to become negative 2, negative 2. Negative 6, 4 is going to become negative 4, negative 6. And negative 4, negative 7 is going to become negative 7, negative 4. Again, if you're having trouble with this, you definitely got to go back and check out videos 3, 4, or 5, depending on which transformation you're having trouble with. This part you should be able to do. Let me see, we got q prime down here. We got r double prime down here. And we have s double prime right here. So that would be after the composition. We did the reflection of the y-axis here, then we did the rotation of 90 down here. All right. That's it. Make sure you list out the coordinates. Okay, and make sure you graph the image. That's what's really important. All right. Next example. This one is one of the most important things because there's a lot that goes into this question. It's usually a 2-point question and it's asked all the time. Describe the sequence of transformations that would map ABC onto DEF. So first, we know that this is our starting point. So we need to go from this triangle to this triangle using transformations. And then, are these two things congruent? Well, we'll get to that part. So how do I get from this triangle here down to this triangle? Well, I want to match A to D, B to E, and C to F. All right. So the first thing I would do is I would do a reflection over the x-axis. And when you answer this question, please make sure you are specific. Do not just say reflection. You must say reflection over what? Over the x-axis, over the y-axis. Whichever line you're doing, make sure you point it out. Now, to make this easier for you guys to see, I'm actually going to do the reflection. This would be B prime, this would be A prime. This would be C prime. Okay, so that would be my first step. And then the next thing, how would I get from A to A prime to D? And this is what's important. Remember, we talked in, I think, video 2 about lining things on top of one another. I need to get point A to point D. So that's going to be 1, 2, 3, 4, 5, 6. And I would check to make sure that all the other points are the same. I should check that C goes to F on 6 points as well. Okay, and that is, these are both 6. And if I did B to E, it would also be 6. So my two transformations, first I would do a reflection over the x-axis, then I would do a translation of 6 units to the right. Now, this is not the only answer to this question, so if you're seeing something different, make sure you come and see me, and we'll talk and make sure that's right. If I wanted to write this in notation, I would do it like this. All right, that's important. All right, that's the first part. You can do this either way, okay? And make sure that all of the points line up. If all of the points don't line up, then something's wrong, and that's going to affect the next answer or the next part of the question. So next part of the question says, is triangle ABC congruent to DEF? Now, this is the one that comes up a lot. So are they congruent? Well, to answer that question, we're going to go back up to here. Was there a sequence of rigid motions that mapped ABC onto DEF? If yes, then the figures are congruent. And I know that it's yes because a reflection and a translation are both rigid motions. So we could say here, yes, they're congruent. Yes, triangle ABC is congruent to triangle DEF because there is a sequence of rigid motions that map ABC onto DEF. Okay, and we could also go further if we wanted and say that rigid motions preserve distance and angle measure if we wanted to go one step further. All right, one last example here. Okay, simple one of 1 point. So find the coordinates of 2, 4 under the composition y-axis and translation of 3, negative 5. Remember, this circle stands for composition, so that means we go right to left. So make sure you start with the translation here. So I'm going to start with the point 2, 4, start with my translation of 3, negative 5. Quick review of translations. Take 3, add it to 2, get 5. Take negative 5, add it to 4, get negative 1. Then I would do my second one. So now I'm going to do my reflection on the y-axis. And I'm going to change the x value. So that's going to give me negative 5, negative 1. That would be my final answer. All right. So it can be as simple as doing 1 point. It can be as complicated as doing a full triangle or a quadrilateral. Or it can be to the point where you're given two images and you have to figure out how to get from one to the other. Those are the big 3 ways that this topic is asked. All right. So if you have any questions, fill it out, get a short summary, try the practice. All right. And then we got one more video after this, and then we'll get a test. So just remember, you do have a mastery check at the end of this video. So when you're ready for that, let me know. And I'll see you guys for the last one in video 7.